There is a paradox sitting at the center of everything you have been told about carbohydrates, belly fat, and the human body, and it is one that modern nutrition science has spent decades trying to explain away rather than honestly confront. The Japanese eat white rice almost every single day, not occasionally, not in tiny ceremonial portions, every day, as a staple, as the foundation of nearly every meal, in a country where rice is not a side dish, but a cultural cornerstone. And yet, Japan consistently ranks among the leanest nations on Earth. Rates of obesity are among the lowest in the developed world. Visceral fat, the dangerous deep abdominal fat wrapped around your organs that drives heart disease, diabetes, and metabolic dysfunction, is significantly less prevalent in traditional Japanese populations than in almost any Western country. For a long time, scientists and nutritionists dismissed this with a single word: genetics. They said the Japanese were simply built differently, that their DNA protected them from the metabolic consequences that white rice would impose on a Western body. It was a convenient explanation. It was also wrong. Because when researchers began studying what happened to Japanese individuals who moved to the United States and adopted Western eating patterns, the genetic argument collapsed completely. Within a generation, sometimes faster, visceral fat accumulated at the same rate. Metabolic disease followed. The leanness disappeared. The rice had not changed. The genetics had not changed. What changed was everything surrounding the meal, and that is the insight that unlocks everything. The Japanese do not have a metabolic advantage built into their DNA. They have a biological system built into their daily habits, and that system operates on a level most Western health advice never reaches. It does not work by restricting calories or eliminating food groups. It works by systematically removing every biological reason the body has to hold on to visceral fat in the first place. What follows is not a collection of wellness tips. It is a 5-part biological sequence. And understanding how these 5 mechanisms work together is the difference between fighting your body and finally giving it permission to change. The first mechanism begins not with exercise or restriction, but with a fermented food that barely exists in Western nutrition conversations: natto. If you have never encountered natto, it is a traditional Japanese breakfast food made from fermented soybeans. It has a strong smell, a sticky texture, and a flavor that takes most people time to appreciate. But its biological significance has nothing to do with taste. To understand why natto matters for visceral fat specifically, you need to understand something about the nature of visceral fat that most fat loss strategies completely overlook. Stubborn because of hormones or caloric surplus, it is structurally isolated. Compared to the fat sitting just beneath your skin, visceral fat is poorly vascularized, meaning it receives significantly less blood flow. Blood is the transport system for everything in the body, including the fatty acids that need to leave a fat cell and enter circulation before they can be burned as fuel. When blood flow to visceral fat is compromised, even a body that is sending the right hormonal signals to release fat finds itself blocked at the infrastructure level. The signal says release, but the pathway does not exist to carry the released fat anywhere. This is why so many people who are genuinely doing everything right, eating carefully, exercising consistently, managing stress, still find that belly fat barely moves. The problem is not effort. The problem is circulation. Natto addresses this through an enzyme produced during its fermentation process called nattokinase. This enzyme does not burn fat, and it does not directly stimulate any fat loss hormone. What it does is improve microcirculation by supporting the breakdown of fibrin structures in the blood, allowing blood to move more freely through the smallest vessels in the body. When microcirculation improves in and around visceral fat tissue, the transport network that was previously blocked begins to reopen. Fatty acids can finally leave the fat cell, enter the bloodstream, and become available as fuel. Nothing else in the fat loss process can work properly until this step happens. But nattokinase is only half of what makes natto metabolically significant. Natto is also one of the richest dietary sources of vitamin K2, a nutrient that most people in the West are severely deficient in, and that plays a role in metabolism that is almost never discussed outside of specialized research. Vitamin K2 activates a hormone called osteocalcin, which is produced by bone tissue. Most people think of bones as structural, inert, simply the scaffolding the body hangs on. But bones are an endocrine organ. They produce hormones. When osteocalcin is properly activated by vitamin K2, it sends signals to the pancreas that improve insulin responsiveness and communicates with fat tissue to stimulate the release of adiponectin, a hormone that directly supports fat oxidation and insulin sensitivity. Without sufficient K2, this hormonal loop is incomplete. With it, bones shift from being passive structures to active metabolic participants, quietly improving the body's ability to use energy and discouraging the conditions that allow visceral fat to accumulate. The Japanese do not eat natto because they know any of this. They eat it because it has been part of a traditional breakfast for centuries. But that unremarkable morning habit is quietly maintaining a biological environment where visceral fat has no structural advantage, where circulation is sufficient, where the hormonal infrastructure supports fat release rather than fat storage. Before the body can burn fat, it must first be able to reach it. Natto clears that path. Once you understand that the first obstacle to visceral fat loss is biological infrastructure rather than effort, a second question becomes unavoidable. How do the Japanese eat white rice every single day without triggering the insulin chaos that Western nutrition insists carbohydrates inevitably cause? The answer is not portion control. The answer is biological context. In the Western diet, carbohydrates are frequently consumed alone, eaten hot, eaten fast, and eaten in a state of low awareness. A bowl of white rice consumed that way behaves exactly as critics of carbohydrates describe. It is rapidly broken down into glucose, floods the bloodstream, triggers a sharp insulin response, and sends a clear signal to the body to store energy rather than release it. But rice in a traditional Japanese meal is never consumed that way. It is almost always surrounded by elements that fundamentally alter its biochemical behavior before it even reaches the small intestine. The first of these elements is acid. Traditional Japanese meals routinely include vinegar-seasoned rice, pickled vegetables, fermented miso soup, or other fermented components. These foods introduce acetic acid and lactic acid into the digestive environment. When these acids are present alongside starch, they slow the activity of alpha amylase, the digestive enzyme responsible for breaking starch into glucose. The starch is not blocked from digestion entirely, but the rate at which it converts to glucose is significantly reduced. When you look at all 5 of these mechanisms together, the picture that emerges is not a diet, it is a biological environment. An environment where fat cells have sufficient circulation to release their contents, where glucose enters the bloodstream slowly enough that insulin never needs to panic, where cortisol is low enough that the body no longer believes survival depends on holding on to stored fat. where leptin sensitivity is intact so the brain can accurately read the body's energy status, and where fat-burning signals last long enough to translate into actual change. None of these pillars works in isolation. The system only functions when all five are present, reinforcing each other, creating the conditions under which visceral fat has no remaining biological justification. This is why people who diet aggressively, exercise consistently, and fast regularly still struggle with belly fat. They are changing behavior without changing the underlying message the body is receiving. And the body only releases what it no longer believes it needs for survival. You do not need to force your body to get lean. You need to give it absolutely no reason to stay fat.
The fat-burning signal that the body already generated through movement or low insulin simply lasts longer. This is not about stimulating more fat burning. It is about extending the duration of the fat burning that is already happening. Green tea also modestly activates brown adipose tissue, a type of metabolically active fat that generates heat by burning energy. And the combination of caffeine and L-theanine in green tea produces calm, sustained alertness without the cortisol spike that high-dose stimulants create. Fat-burning signals remain active. Cortisol stays low. Lipoprotein lipase does not reactivate. Visceral fat is not pushed back into storage. The Japanese do not drink green tea to lose weight. They drink it because it is part of the daily rhythm of life. But that unremarkable habit is quietly doing something precise and powerful at the hormonal level, making sure that every other mechanism in the system runs long enough and cleanly enough to produce a result.
The fifth and final mechanism addresses a question that almost nobody asks when designing a fat loss strategy. Once the body is releasing fat, how do you keep that process running long enough to matter? Norepinephrine is the hormone that instructs fat cells to initiate lipolysis, the release of stored fatty acids into circulation. It is the unlock signal for fat stores. The problem is that the body produces an enzyme called COMT, whose specific job is to break down norepinephrine and return the system to baseline. In modern physiology, this enzyme often works very efficiently, meaning that even when the body successfully triggers fat release through movement, fasting, or activity, the signal is degraded quickly and the fat-burning window closes before meaningful oxidation can occur. Green tea addresses this through a polyphenol called EGCG, which inhibits COMT activity. When COMT is suppressed, norepinephrine is broken down more slowly. Stopping at small pauses between key ideas means that when leptin's signal reaches the brain 20 minutes later, the system registers satisfaction naturally and cleanly. No surplus, no storage signal, no leptin resistance developing over time. Chopsticks play a quiet but significant supporting role in this. They are not more virtuous than forks, but they are structurally slower. They encourage smaller bites, longer chewing, and a more deliberate relationship with the pace of eating. That slower pace gives leptin and the other satiety hormones, CCK and GLP-1, the time they need to communicate with the brain before overconsumption occurs. The rhythm of eating becomes the mechanism of regulation. And when leptin sensitivity is preserved, the downstream benefit extends far beyond reduced caloric intake. The brain no longer perceives an energy threat. Visceral fat loses its role as a protected reserve and becomes accessible fuel. The fourth mechanism addresses something that almost no conventional diet advice touches: the timing of the satiety signal. Leptin is the hormone released by fat tissue and the gut that tells the brain energy needs have been met and eating can stop. It is a precise and elegant system when it functions correctly. The problem is that leptin does not work instantly. From the moment food enters the stomach to the moment the brain registers the hormonal signal and responds to it, approximately 15 to 20 minutes pass. This delay is biological and cannot be overridden by discipline or intention. When a person eats quickly, past the point of hunger and toward the point of complete fullness, they consistently outrun the signal. By the time leptin reaches the brain, the body is already in energy surplus.
When this happens repeatedly, the brain gradually becomes less responsive to leptin's message. Leptin resistance develops, a state in which the brain behaves as though the body is starving, even when fat stores are abundant. Hunger persists. Visceral fat is protected. The harder the person tries to eat less through willpower, the more the biology fights back. The Japanese principle of hara hachibu, eating until approximately 80% full, is a direct solution to this biological timing problem.
These patterns are processed by the brain without effort, inducing a state of soft fascination where attention is gentle, restorative, and metabolically inexpensive. Modern urban environments are built on straight lines, sharp angles, dense signage, and screens. Processing these geometries requires directed cognitive effort, which is physiologically taxing and keeps the stress response quietly activated even when no obvious threat is present. Prolonged exposure to that environment maintains cortisol at a level that keeps visceral fat locked in survival mode. Shinrin-yoku interrupts that loop. When cortisol drops, lipoprotein lipase activity decreases. When that enzyme is no longer aggressively pulling fat into storage, visceral fat loses its biological justification. The Japanese do not need a forest. A park works. A tree-lined path works. A screen-free walk in any environment with natural elements works. What matters is giving the nervous system consistent and genuine signals that the environment is safe. Because the body will not release stored energy until it believes that releasing it is not a survival risk.
The Japanese practice of Shinrin-yoku, often translated as forest bathing, is not a spiritual wellness trend. In Japan, it is a formally recognized medical therapy prescribed by physicians to manage hypertension, anxiety, and the physiological consequences of chronic stress. The mechanism is chemical and neurological. Trees release compounds into the air called phytoncides, volatile organic molecules that, when inhaled, have been shown in controlled studies to reduce salivary cortisol levels, lower blood pressure, and activate the parasympathetic nervous system within 15 to 20 minutes of exposure. The nervous system shifts from a state of defense to a state of recovery. But phytoncides are only part of the picture. The human brain evolved in natural environments over hundreds of thousands of years and is deeply attuned to the patterns found in nature, the fractal geometries of leaves, branches, water, and clouds.
Add small pauses. Key ideas. This is not a psychological failure. It is a hormonal one. And the hormone responsible is cortisol. When cortisol is chronically elevated, the body reads its environment as dangerous. In a state of perceived danger, burning stored energy is reckless. Storing it, especially as visceral fat, close to vital organs, is rational from a survival standpoint. Cortisol activates an enzyme called lipoprotein lipase, which actively pulls fatty acids into fat cells and locks them there. A person can have stable insulin, good circulation, and excellent dietary habits, and still find visceral fat immovable if cortisol remains persistently high. The body will not release what it believes it might need to survive.
Resistant starch does not convert to glucose in the small intestine. It does not spike blood sugar or trigger an insulin response. Instead, it travels to the large intestine, where it becomes food for the gut microbiome. The bacteria there ferment it and produce short-chain fatty acids, particularly a compound called butyrate. Butyrate is not a waste product. It is a signaling molecule that improves insulin sensitivity at the cellular level and enhances the body's capacity for fat oxidation. The same rice that would destabilize blood sugar when eaten hot and alone becomes a tool for improving metabolic function when cooled and paired with fermented foods.
And the effect does not end with that meal. Resistant starch creates what researchers call a second meal effect, where the metabolic benefits of one strategically composed meal carry forward and improve how the body handles glucose at the next meal. A well-designed lunch can make the body more insulin sensitive at dinner. This is the Japanese approach to carbohydrates. Not restriction, not fear, domestication through biology.
Add small pauses between key ideas. Instead of a wave of glucose entering the bloodstream all at once, glucose trickles in gradually. Blood sugar peaks are lower. The insulin response is milder. The pancreas is not pushed into emergency regulation. A sour side dish that costs almost nothing and requires almost no thought is quietly flattening the glucose curve in a way that changes the entire hormonal conversation of the meal. The second layer of protection is even more remarkable because it comes from something as simple as temperature. In Japan, rice is frequently eaten at room temperature. Bento boxes, onigiri, sushi, cooled rice served as part of a balanced meal. This is not just cultural habit. When cooked starch cools, its molecular structure undergoes a transformation called retrogradation. The starch molecules rearrange themselves into a form that the digestive enzymes in the small intestine cannot efficiently break down. This is called resistant starch.